Hello, I'm Dr. Harper. This video is a homework Excel tutorial in Linear Programming Operations Management Part B. So let's bring up the homework. The Silver Company. The Silver Company is planning the monthly production of technical products required as part of their NASA 3-year project. Each product must pass through each department. The times to produce one product for each department was presented below, along with the monthly capacity and hours for each department for this project. Although the maximum level of production or a specific level of production for each product are not required, the minimum level of production is 80 for each product according to the contract. The unit profit from each production has been determined and presented in the table below. So the minimum production of 80 is one of the constraints. And so let's see what the production is for this problem. It's a product mix problem, and it's 4 products, and so it's 4 dimensions. So let's take the problem here, Control C, and let's bring in Excel. And let's come down here a ways, and let's Control V and paste this, and there it is. And let's enlarge this so we can see what's going on. Very good. Okay. And then let's take these away and format. Looks good. Okay, let's bring this up. Let's bring this up like this. And we know that we have a minimum of 80. Okay, and this is going to equal 80 and bring this over. Now, we know that's going to be the minimum of our production. So this is going to be optimal mix, and we'll highlight these because we know, and box this in, and just to be safe, shade this in so we know what it is. Over here is going to be the left-hand side values. That equals the sum product of the coefficient in the constraint set, which are these, times our optimal mix, which are these, F4, to fix them. And now we bring this down to each constraint: wiring, drilling, assembly, inspection, and our profit. So let's box the profit in because that's going to be our objective function. We want to maximize our profit by changing these such that these values do not exceed our capacity. So here's our problem. Let's go to Excel, Solver. Let's go to Solver in Excel. And so objective function is going to be that cell right there. By changing cells, by changing these cells right here. Oops, that's wrong. By changing our decision variable cells, which are these right here. And now we add our constraint. And it's the values here are going to be less than or equal to the values of our capacity. Say OK. And then we add that the value of our production has to be greater than or equal to, greater than or equal to the minimum. Because it has to be more than 80. OK. And now we say non-negativity constraints to non-linear. Make sure it's linear. Simplex algorithm is linear. Solve this thing, and there's our solution. Let's see. Solver found a solution. All constraints, optimality conditions are satisfied. Keep solution, yes, and we're good to go. There's our solution, $17,000, and so the maximum profit is $17,000. Which resource has the greatest amount of hours not utilized at the optimal solution? Okay. Well, let's see what's remaining here. That's simply going to be our capacity minus what is used. And so all that's used, and so we come down and do all 4 of these, and we see that wiring and the inspection, that's 100% utilized. But drilling and assembly, there are some capacity hours not utilized. And it says the greatest amount of hours not utilized is going to be in assembly. So assembly has the greatest amount of hours not utilized. Okay, what is a profit for the mix that is exactly 50% above the minimum production level for each product? Okay, so let's come down to here and let's say, fine, let's do this again. Let's box this in. That was the next question, just so we know what we're doing here. Now, the next question is the mix of 1.5 times the mix. Okay, that's gonna, we'll set it that way, equals 1.5. This is 50% more of the minimum, which is 80. What's it gonna say? Equal 1.5 times 80, and that'll be 120. And there it is. Okay, what's our profit? Profit right here equals the sum product of the coefficients, which is this is the mix, these are the mix, comma, times our coefficients, our unit profits, which are these right here, in parentheses, return, and that right there, we'll box this in, and there's our solution. 13,080, and so the profit is 13,080. And so here's a product mix LP when we have 4 dimensions, 4 different products with some requirements in there. So that's all I have for this part B. Hope this helps. Between now and next time I see you, take care.